Hello everyone, in this two-part video series I'll be going over how to cut tube using our tube jig on our CNC router, as well as using multiple work coordinate systems. In part 1 I'll be going over how to set up your toolpath using HSM Works as well as multiple work coordinate systems, and then in part 2 I'll be going over how to zero the devices and run the toolpath. So the part we'll be cutting today is just a section of a sample of a drive tube. So we have here bearing hole as well as a couple half depth pockets, so these pockets only go halfway through the tube. First thing you're going to do is you're going to set up your coordinate systems. So go here, coordinate system, and when we're cutting the part, this side will be facing up and the CNC will be zeroed along the x-axis will be zeroed along here and the y-axis along here. So we're using this corner here. The x-axis will be this axis, and the y-axis this axis, and the z-axis this axis. So you're just going to flip those around until it lines up properly. So if you imagine if the entire thing were rotated 90 degrees to the left, your z would be pointing straight up, your y would be going lengthwise, and your x would be going this way, which lines up with how it should be. So we have the x-axis going along this way, y-axis going this way, and then the z-axis is just right on top of this tool part. Next, you're going to create your job. So to set up your multiple work coordinate systems, you're going to come down here to post-processing and work offset and check the multiple WCS offsets. So this first one is the number of workpiece duplicates. Basically, as you see here, the total number of parts you need to make. So we'll be making 2 of these in one toolpath, and then the increment is 1 because we'll be using G54 as our first work offset and G55 as our second work offset. And then you're going to want to set this one to 1. Next, we're going to want to create the actual toolpath. So first we'll be using the bore feature and a 3/16 end mill at 30 IPM, 19,000 RPM to cut out the hole. So just like that. And then we're going to want to take our track type 0.5, clearance height 0.4, and our bottom we're going to set that 50 thou below the tube wall here, or the bottom of the hole, just to ensure that we cut all the way through. And we'll be going at a 0.07 thread pitch cutting. And then you can leave linking alone, just like that. And then we're going to use the pocket feature to cut out all of the pockets here. And we're not using a contour here because we need the entire area here level, not just the outline of it. So we'll actually be cutting this at 65 IPM. We're going 21,000 RPM and 65 IPM. Just select each of these pockets. And then for the bottom one, you're going to keep that at 0 because we don't want to go any deeper than the actual pocket in the model is. And then we'll be going, you're going to uncheck stock to leave since we want the final dimension when we're cutting this pocket out. And we're just going to go one depth here. So you're going to make sure multiple depths is unchecked. And then for linking here, we're going to set our ramping to helix. And the only thing you need to change here should be this ramp clearance height. So that's basically just the height above the top of the model here at which it starts helixing. So it's 20 thou. And there we go. So we have it. You can see it helix in, and then it cuts out the pocket. And so when you're posting this, instead of posting these to just the toolpaths, you're going to post the entire job. So when we go here, we're going to post process. We're going to post this. I'll just call this. Post test. And when you open this up, you'll see that it has the name, the G code. It has the name of each feature that it does. So for this, you can see here it goes bore 1, G54. G54 is that first work offset. It does bore 1 at that first work offset, and then it does the pocket at that first work offset, and then it does the bore 1 at the G55 work offset, which would be the second tube over here, and then it does the pocket for that one too. Now, say I had some holes here that needed to be bored out, some smaller holes like a number 10 clearance hole. In that case, I want to optimize my my cutting time, so I'm going to have it so that each tool cuts, and then you do a tool change, and then you cut all the tool paths for that tool. So I would basically be doing all the number 10 holes using the 1/8 inch end mill on here, and then on the second part, that would be in the second vise, I would be doing all the number 10 holes or whatever features using a different tool on that as well, and then I'll switch the tool to the 3/16 end mill and then cut out all the pockets and bore out that bearing hole on both. So this reduces the number of tool changes you need to make to basically 1 between the 1/8 inch end mill to the 3/16 end mill. And so to do that, you're going to want to do order by tool. So that's what ordering by tool does. It does each tool's tool path, and then there's a pause in between so you can change your tool, and then it cuts using the next tool. Order by operation is simply the order here, and then or actually order by operation is it goes this bore 1 first, and then it does the 2D pocket first, and then it does the 2D pocket. So we'll be just doing order by tool, even though it's the same tool for all of them. And then you're going to make sure that when you post the entire job. So you can see here now, I have, when it orders by tool, it also orders by operation. So we have bore 1 on the G54 work offset, and then it does the bore 1 on the G55 offset. This basically means first work offset, first part, it does the bore hole here, and then it goes over to that second tube and then makes that bearing hole there. And then it comes back over here, does the pocket, and then it goes over to the second tube and does the pocket there. And then after you do this side, you want to flip that over, flip the part over, and to make the toolpath for the other side. So we have the coordinate. When we flip it over 180 degrees, this side will be the side that the 0 is on. So x-axis here, y-axis here, and then z-axis along here. Flip those until it lines up properly. And then you're going to make sure to create a different job for this. And since we'll be doing 2 of these, use 2 work offsets as well. We're going to work offset. We have multiple work offsets. We'll be doing 2 duplicates. So your first work offset to the first. And then we'll be doing the same thing where we order by tool. And then we're going to want to bore out that center hole again using 3/16 end mill at 30 IPM. Here. And then using the 2D pocket to pocket all the pockets using 65 IPM. 65 IPM, 21,000 RPM. So you're going to make sure that all of the arrows are on the inside as well of the pockets. But if it's not, then you just hit the reverse button. Let's see here. Helix is in, and then it cuts out the pocket. And same thing as before, you're going to post that job. Let's say back side of it. So let's see, we have our bore first at G54, and then our bore at G55, our pocket at G54, and our pocket at G55. So depending on how many vices you have and how many of the same part you want to make, you can go anywhere from G54 work offset all the way to G59, which gives you six work offsets you can do. But yeah. And so in part 2, we'll be showing you how to zero to the vise using an edge finder and then running the part. So this is just the finished part here. You can see we have the part in both here. And so it cuts out this part first, or cuts out the bore first, and then the second bore, and then the pocket here, and then the pocket here.